Working with the rules of BODMAS when it comes to fractions is a vital part of being able to do any calculation that we work with in maths. Now, what I want to talk about in this one is I want to look at adding and subtracting fractions and mixed number values. And there's a key rule that needs to be followed whenever we add or subtract a pair of fractions or mixed numbers with a fractional part. And that key thing is that the fractions must have the same denominator in order to be able to add or subtract them. So for example, if I imagine I have a circle and I have it split into three sections here. So there's 1/3, there's another third there, and I want to do 1/3 plus 1/3. What I'm going to get is 2 of the thirds. You can imagine, similarly for subtraction, what I could do is take a circle and imagine I split it up into 5 equal pieces. And I'll take 1, 2, 3 of them. So that's 3/5. And let's imagine I want to take one of these fifths, so let's say this element, and I want to subtract it from the overall amount. So I want to take away that 1/5. Now because they're the same denominator, I've got 3 of the fifths, I'm getting rid of them. I'm going to end up with 2/5. Now you notice for each of these calculations, all I've done is added or subtracted the numerators. The denominators stayed the same because I've not changed the fractional portion of the overall shape or the overall quantity that I'm taking. This is why fractions must have the same denominator to be able to add or subtract them. However, a key question that comes up is what do we do and how do we approach it if the denominators are different? This is quite a frequent question and a frequent thing that we have to deal with. But there are really two techniques that we can use and that are universal to both adding and subtracting a pair of fractions that can work for this. Now let's imagine I'm going to focus on the adding question first. So I'm going to focus over here. There's two techniques that I have to do, both of which do the same fundamental thing, which is make the fractions over the same denominator. Now the first technique I can look at is I imagine I take the calculation, and what I'll do is I'll take the fraction on the right and I'll multiply top and bottom by the denominator of the left-hand fraction. And I'll do the same for the left fraction, except I'll multiply the top and the bottom by the denominator of the right-hand fraction. What that'll then do is that'll let me write the fractions as 5/20 plus 12/20 here. Now these are the equivalent fractions. All I've done is instead of simplifying fractions, you can essentially think of it as unsimplifying them. So I've unsimplified those fractions to put them into a common denominator, which means I can then just add the numerators as we did before. Now if I get to this stage and I can simplify back again, I simplify if I can. If not, then I don't worry about it. Another technique we can use is a technique called the kiss and a smile. Now in order to do that, what we imagine we do is we take the pair of fractions and we give them a kiss and we make them smile. Now what this does is this indicates to me the operations I'm going to do. So each element of the kiss part here indicates multiplication, as does the smile element here. What it tells me is that for this one, I'm going to do 1 times 5 because those two numbers are linked. My top right numerator is going to become 3 times 4. My add in the middle, my addition is not going to change. And my denominator is going to become 4 times 5 on both of the fractions. So what I'm going to end up with is 5/20 plus 12/20. And that is the exact same as what I've got over here. It's two different ways of setting out the working and setting it up so that I'm able to make them over a common denominator and then be able to use them. Now that's for addition, and funnily enough, subtraction, actually the technique doesn't change. So again, I could look at the calculation and say, right, I've got 3/4, take away 2/5. I'm going to multiply everything on the left fraction by the denominator of the right, and I'm going to multiply everything on the right by the denominator of the left. What that'll then give me is 15/20, take away 8/20. So in this case, that'll leave me with 7/20. Similarly, I could have used the other technique, which is 3 over 4, take away 2/5, and used the kiss and a smile for it. I'd end up with 3 times 5 as my top left numerator. I'd end up with 2 times 4 as my top right numerator, and then my new denominators would both be given by the 4 times 5. So in this case, I'd end up with 15 over 20, take away 8 over 20, and again, the exact same calculation and the exact same solution. So I've got 2 different ways of laying out, but the fundamental thing for each of them is that I'm putting it over a common denominator. That is the key step. We can't do anything else until they're over that common denominator. Once they are, it's simple addition and subtraction involving the numerators. And then simplification if we can, but that's not always necessary. Now, to add a level of complexity into this, we can ask ourselves what happens if we have mixed numbers. Let's bring them into play here. Now, there's a couple of ways we can approach these ones as well. They're both fundamentally the same thing, because in order to do the calculations, we have to have a common denominator on the fractions. But we do also have the whole number parts. Now, there's 2 ways in which we can approach it. One way is to separate them. So what I can say is fine. If I'm going to look at the one on the left, I could do 3 plus 2, which is 5. So there's my whole number parts. I could do a quarter plus 3/5, group my fractional sections together and use whatever technique I want in order to be able to do that. So what I'd end up with here is 5 over 20 plus 12 over 20. So I get 17 over 20. And then I could stick them together. So I've got 5 whole ones. I've got 17 over 20. So my overall answer is equal to 5 and 17/20. Similarly for the subtraction, if I focused on that way and I took the whole number parts together, I'd do 3 take away the 2, so I'd get 1 for that. And I'd do a quarter take away 3/5. So that would end up giving me 5 over 20, take away 12 over 20, which would give me negative 7 over 20. And then if I combine them, I'd end up with 1 and negative 7 over 20. Now, this brings an issue into play for this one though, because it's a negative fraction. I can't have a negative fraction as part of a mixed number in this manner. So what I have to do is take that one and say, right, I'm going to have to subtract 7 over 20 from it. Well, I know 1 is the equivalent of 20 over 20. So 20 over 20, take away the 7 over 20, just leaves me with 13 over 20. We have to remember that if this fractiony part here is negative, we have to then take it away from a whole part of the number. Similarly, if we'd ended up with a fraction part that was improper and bigger than a whole, we'd have to separate it off and be able to combine it using that. Another way I could have done these two is I could have made the mixed numbers into improper fractions and work with them in that manner. So if I looked at the left again with the addition, I could rewrite it as 13 over 4 plus 13 over 5. And then follow my same steps, I would just have slightly bigger numbers to work with. So I could end up with 65 over 20 plus 52 over 20. And then when I add the 2 of them together, I'd end up with 117 over 20, which funnily enough gives me the same answer of 5 and 17/20. Could have done the similar way for the subtraction. So I could have written it as 13 over 4, take away 13 over 5, and then put them again over the common denominator similarly, and ended up with 65 over 20, take away 52 over 20, and ended up with 13 over 20, again, same as what I had before. So I'd have got the same answer for each calculation, regardless of which of the 2 techniques. Sometimes it's better to use some of the others. So for example, in the subtraction one, using the improper fractions here actually saved me having to deal with a negative 7 over 20 at the end of it. So sometimes it is better to use certain things, other times not so much. It doesn't really matter too much. You just have to make sure you get your head around the technique that you choose to use and how you choose to use it. Now here's 4 for you to have a crack at, so pause, have a go at them and come back and check what you've done with what I'm going to show you. So what I'm going to do for this one here, again we have to remember put them over a common denominator. So I'm going to multiply the fraction on the left by 8, the fraction on the right by 5. So what I'm going to end up with is 24 over 40 plus 35 over 40. There we go, it's over a common denominator. And that then gives me 59 over 40. It's an improper fraction, so I can simplify it down and I'll end up with 1 and 19/40. Second one here, top right, the 4 over 7 take away a half. Again, common denominators is the key first step. We have to have that. So I'm going to multiply both elements of the left fraction by the denominator of the right, so 2. I'm going to multiply both elements of the right-hand fraction by the denominator of the left, which is 7. And I'm going to end up with 8 over 14. Take away 7 over 14. And then calculating this, quite simply, gives me 1/14, 1 over 14. Bottom left one brings into play the mixed numbers part of it. Now this one, what I'm going to do is I'm going to separate it for this. I'm going to say, right, so I've got 1 plus 3 gives me 4. I've then got 6 over 7 plus 1 over 5, the fractional elements of it. And if we follow our standard technique of it, what we'll end up with is 30 over 35 plus 7 over 35. And that gives me 37 over 35. Now this is improper here, this fractional part, so I have to make this a mixed number. And what that'll do is that'll give me 1 and 2/35. So I then combine my whole number part here, the 4 and the 1 and 2/35, and I'll end up with 5 and 2/35 for that one. The last one I've got is this subtraction one here. Now one thing I can instantly look at is say a half is smaller than 2/3. So if I subtract them separately, I'm going to end up with a negative fraction. And I'll have to deal with that, which could be a bit of a pain. So what I'm going to do actually for this one is I'm going to take the initiative that I mentioned earlier and have a think about which is easiest, and I'm going to make them improper fractions. So I'm going to end up with is 9 over 2 take away 8 over 3. And then I'm just going to follow my standard steps. Fraction on the left multiplied by 3 top and bottom. Fraction on the right multiply top and bottom by 2. So what I'll end up with is 27 over 6 take away 16 over 6. If I then do that, what I'll end up getting is 11 over 6. There's the improper fraction part of it. If I then simplified that to a mixed number, I'd end up with 1 and 5/6. So there we go. For each of them, we pick the technique that works for us. However, the key part of each technique, you'll notice throughout, is I've always put them over a common denominator. That's fundamental. You can't do anything without that. If we don't have a common denominator, we can't combine them. Simple as that. So we have to remember the rules for this. Well, the rules are quite simple. Biggest one, denominators must be equal. We can't add or subtract a pair of fractions or mixed numbers if the denominators of the fraction parts are not equal. When the denominators are equal, we can add or subtract the numerators because that's the key focus of where the operation is. The next part would be for mixed numbers, we've got the two techniques we can choose. We can either use improper fractions or split it into whole numbers and fractional parts. Again, have a think about the operation you're doing and the size of the fractions. Which one's the best to use? Which one will make your life less complicated in the long run? Then we have to say, bearing that in mind, if the fractional element is above 1 or below 0, this needs sorted in the way we demonstrate it. So if it's above 1, we have to write it as a mixed number and combine it. If it's below 0 and it's negative, we have to take it off and combine it in that manner. And then the final rule, we always remember with fractions, we always simplify our solution if we can. Bear those rules in mind and it'll be fine. Just remember, think smart, solve fast.